Okay, we're going to talk about some vector operations and unit vectors. First of all, scalar multiplication, basically taking a vector, and if this is v and I want half of v, it's half the length. If I do 2v, it's double the length. If I do negative v, it's in the opposite direction, or I can change two things at once. I can make it longer and in the opposite direction. Vector addition, you don't change their lengths and you don't change the direction, but you do position them so that the terminal side of the first point coincides with the initial side of the second point. So you always want them to be head to tail. And then you draw essentially the hypotenuse of the triangle and add the components together. Okay, let's start with two vectors, v and w. Let's draw our x and y axes down here. My vector v is negative 2, 5, which means it starts at the origin, left 2, up 5. So here's vector v. Vector w starts at the origin and goes right 3, up 4. Okay, so we've got our two vectors. Now I want to find 2v. Well, if I'm 2v and this is v, I want to go double the distance. So I'm going to be 2 times negative 2, 5. Oops, that should have been a vector symbol, which should be negative 4, 10. Which makes sense because it's going to go this distance plus double more. So twice as much in the x, twice as much in the y. Okay. W minus v means I have to start with w and I subtract v. So I'm going to do w, which is 3, 4, subtract v, negative 2, 5. You just add their components together. 3 minus negative 2 is going to be 5. 4 minus 5, negative 1. Now, what does this look like graphically? It's like adding the negative. It's like taking the w, adding the negative v. So I've got my w already drawn on here. And I need my v, same, pointing in the same direction, same length, but I need it to be going in the opposite direction. So instead of going, what is that, negative 2, 5, so it's going to go 2, 3, 4, down over 2, it's going to go like this. So it's the exact same length, perfectly opposite direction, gives me this vector that I get right here. This is negative v, and I get this vector right here, which turns out to be 5, negative 1. Right 5, down 1. Okay, I'm going to erase some of this to get to the third one. So it's not letting me erase everything, so let's just keep going. This is my v, and I want to add onto it 2w. So I'm going to take my w, essentially, right here, slide it up here so it's on the end, and double its length. So here's what it's going to look like. It goes over 3 and up 4. So 1, 2, 3, 1, 2, 3, 4. So it's going to go here, but it's going to go double that. So it actually goes a little further. And then when I add them together, I'm going to get this answer. So I want you to understand, to know what it's going to look like graphically as well as mathematically. The math isn't hard, but you've got to be able to see it to know if your answer is reasonable. So if I take v, negative 2, 5, and I add on 2 of w, so this is still negative 2, 5 plus 6, 8. So now this is negative 2 plus 6 is 4. 5 and 8 is 13. Now does that seem reasonable for this point up here to be 413? Looks like it to me. Okay, try this one on your own. Draw your two vectors out and then subtract them. Remember, this is just u plus negative v and 2u plus negative 3v. Draw them out. I want to see the answer graphically and algebraically. Okay, there are my two vectors. Now I'm going to take u and add on negative v. Okay, so v is on there. V is exact same slope, exact same length, just a different direction. I add them together. Remember, we always add them head to tail. My resultant vector, if I do it by hand, I'm going to have 1, 2 plus negative 3, 1. So that's 1 minus, or this is 1, 2 plus negative 3, negative 1. So this leaves me with negative 2 and 1, which is exactly matches what I drew right there. Okay, I've drawn 2u, just double the length of u, and then I have to subtract 3 v's. So here's backwards 1v, backwards 2v, backwards 3v. My answer is going to be something like this. So let's see what it turns out to be algebraically. 2u minus 3v. So that's going to be 2, 4 minus 9, 3, which is going to be negative 7, 1. I'd say that's pretty reasonable. Okay, in some cases it's useful to find a unit vector. A unit vector has the same length, same direction as a given vector. So to find this, we take the vector and divide it by its length. The unit vector will have a magnitude of 1, hence unit, and the same direction as v. So basically we're changing it to a length of 1, but we're keeping the same direction. Okay, find the unit vector in the direction of v and verify that the result has a magnitude of 1. So if I want the unit vector, I got to take v and divide it by the magnitude of v. So my v is negative 2, 5. My magnitude, square root of my two legs squared, negative 2 squared plus 5 squared. So this is negative 2, 5 divided by, what is that, 4 and 25 square root of 29. And dividing them both, this is going to give me vector negative 2 over square root 29, 5 over square root 29, or you are welcome to rationalize it, you don't have to. Negative 2 square roots 29 over 29, 5 square roots 29 over 29. Now verifying that it has a length of 1 would be finding the magnitude of that, which is going to be square rooting the square of my two legs. So it's both of these squared. So I'm going to write it in here. Negative 2 square roots 29 over 29 squared plus 5 square roots 29 over 29 squared. And before I make any mistakes doing this, I'm just going to put it all into the calculator. And putting it all in there, this does come out to equal 1, which is exactly what we wanted. Okay, now we're going to talk about components I and j. I is basically your x goes with your x direction, j goes with your y direction, your x component with I, your y component with j. Let u be the vector with initial point 2, -5 and terminal point -1, 3. Write u as a linear combination of the standard unit vectors I and j. So let's get a picture of what this looks like. 2, 5, 2, -5, sorry. So there's my initial point, my terminal point, -1, 3. So here's my vector going in this direction. So what's my x component? So my x component is from the initial point. How far did I go over? Well, I had to go over 2. And then how far did I have to go up? I went up 8. So since I went left, this is going to be a -2. So I'm going to write this as a -2i plus an 8j. And by 2 right here, what I meant was 3. So this changes to a -3i. Forgot I was over 2. So -3i plus 8j is your standard unit vectors. So this is called component form. Okay, try one of these on your own. Come back and check it. Okay, so I drew my 2 points, my -2, 6 and my -8, 3. And my x component, I'm going to the left 6, so -6. I'm going down 3, so -3, -6i minus 3j. Okay, some vector operations, just doing the math. First of all, this should be a v right here, not another j. Okay, find 2u minus 3v. So 2 times u, which is -3i plus 8j, minus 3v, which is 2i minus j. And it's just distribute and simplify. -6i plus 16j minus 6i plus 3j. So that gives me -12i plus 19j. This goes back to the very beginning when I would have been taking 2 times the length of u, which would be at -3, 8. So I would have drawn my graph -3 up 8. And I would have, so it would have been here, and I could have done twice as long. And I could have subtracted 3v. V is 2 to the right, 1 down. It goes here, but it's going the opposite direction if I'm subtracting it. So I would have tacked that onto the end up here. So it would indeed be going in a negative x direction, but a positive y direction.